So welcome to the last part of this session. I work at Red Hat, and I'm only mentioning it here because the OpenHPC project is currently a volunteer project, so we don't have any full-time persons working on it, and seems to be a bit different than from all the other projects I have seen so far. So what is OpenHPC? And seems to be also different from most of the other projects here. We are actually a Linux Foundation project, and we are currently actively discussing if we should join the HPSF or not. The OpenHPC project exists now for 10 years. It was created in 2015, and at this point, we don't really know if the HPSF is the right fit for us or not. And that's also one of the reasons I'm here, to understand better what the HPSF is. It seems to be very focused on software development, and OpenHPC is not about software development. Most of it, it's mainly about integrating existing parts together in a way to make it easy for users, especially users without much experience, to run an HPC systems. OpenHPC is not just a Linux Foundation project, it's also an HPC software stack. I guess that's what most people know when they hear about OpenHPC. This is not our main focus. This is just a part of a way how we want to achieve our goals. The software stack we do it's RPM based. We build on different Linux distributions. Currently we build on RHEL, and we test on Alma Linux and on Rocky Linux. We build and test on OpenSUSE. We build and test on OpenEuler. Those three target distributions, Linux distributions, is what we currently support. And then we support different architectures with our software stack, ARM and x86, 64, different provisioners. We have Werewolf 3 and 4 and Confluent. We have different resource managers, OpenPBS and Slurm. And the idea is we want to help users to get started with an HPC system, but we don't want to force them into anything specific, and that's why we have so many variants we provide for our users. And the actual thing which is the most important thing for us is validated recipes. Validated recipes is basically it's documentation which helps users to go from a bare metal system to a running HPC cluster. And those validated recipes, what the user can download it's a PDF, and it's a couple of pages long, 20, 30, something like this. And it describes everything what you have to do to go to a running HPC system. In addition to the text, we have all the shell commands you have to type in. And what we actually do for each of our releases to make sure that the documentation we write and provide actually works, we take out all the shell commands, put them into a big shell script, and run them through our test CI systems. And the challenge here is that we have so many different combinations, and we want to test them all. So what we do is I already mentioned, we have 4 distributions which we support, 2 architectures, which means we already have to do 8 variants. Then we have 3 provisioning systems. We want to test them all. We have, which means like 24 now. 2 resource managers, around 50, and then we test on an Ethernet and on an InfiniBand cluster. And once all these variants are tested, or once the installation part of the login of the main node and the compute node has been tested, we then submit for each of these variants around 1,000 tests to the resource manager to actually make sure that the installed system is also a working system. So we test that the software is installed. That's easy. You just run the command. We test that the libraries we provide enable you to compile software against the libraries. We test if the results the libraries are producing are correct. And this is the main part of the work we do for our releases. And this is also this is what we want to make sure that it works. We want to make sure that even users without any experience can go use our documentation and then get a running HPC system. I don't know. We have some statistics which I pull from our repository server. As with every open source project, we don't really know how many users we have. This is a graph showing unique users accessing our repository server. In 2024, we have seen 70,000 IP addresses accessing our repository server. So, I don't know, maybe 50% are bots or whatever, which would mean we still have like 30,000 users, which would be really a huge number. And seeing from the feedback we get at ISC and SC, our users are from really small universities to medium-sized clusters to huge clusters. Users are from all over the world with all kinds of systems are using OpenHPC. What's also interesting, or at least I find interesting from the logs, is for all of our DNF-based users, we see that 72% are using Rocky Linux, 12% are using RHEL, 6% ARNA Linux, 4% Oracle Linux, then there are a few CentOS users, and then some undefined strings there. The last slide I have is just about OpenHPC over the last 10 years had 3 major branches. We had 1.x, 2.x, 3.x, and most people are still using the 2.x branches, which is RHEL 8 based. And we are starting to see more and more users on the 3.x branch. And so that's about OpenHPC. We still are discussing if we should join the HPSF, and maybe at some point we will be a part of this community, which would, I think it would be a good fit, although we don't develop software. It feels like the right group of people.
Do we have any questions? Yes, we do.
Quick question. You mentioned that you build for many distributions, or some distributions, and target specific architectures. Could you talk about your testing? I know it doesn't have to be a deep dive, but how do you go about it?
Okay, so our testing, so one of our problems with the testing is we cannot, so we have multiple levels of testing. We test on GitHub, we just do a build, and then we run a 2 Slurm cluster on a single node and submit jobs through Slurm there, just to make sure that the changes to the RPM spec file result in an RPM which still works with all the tests we have for that certain package. And for the release, what we do is we have one ARM cluster and one x86 cluster. We need at least 4 nodes. We need to have bare metal access because we still use, our expectation is that people will use IPMI to control their nodes, and that's why we also want to use IPMI on the nodes. Then we do an automatic installation of the head node of the cluster, and then we run our recipe to install with one of the 3 provisioning systems to install the compute nodes. Then the compute nodes are booting up. Then the resource manager is running, and then we again submit around 1,000 test jobs to the resource manager to see that the cluster we just installed is actually working. And we do this for all distributions and both architectures.
Thank you. Unfortunately, I'm afraid we don't have time for more questions. It's time to thank all our speakers.